For these examples, we want to convert our angle from degrees to radians in simplest form. So we're going to want to remember how to simplify fractions to obtain simplest form. For number 1, we want to convert 90 degrees into radians. So we want to remember what is our conversion factor. Our conversion factor is always going to be 180 degrees equals pi radians. Now let's set up our problem. We always start off with the initial value, so we have 90 degrees. In order to convert 90 degrees into radians, all we have to do is multiply by pi radians over 180 degrees. Okay, I'm just going to extend that because I want to remind you. Radians in this example is in our numerator. The reason why is because that's the value, or that's the unit we want to end in. The unit we want to cancel is this degree here and here. I can only cancel it if it shows up once in my numerator and once in my denominator. Since that's how we set it up, then our degrees will cancel and our final answer will end up in radians. All that's left for us to do is multiply and simplify. So when we multiply this is technically 90 degrees over 1, so we multiply across and we get 90 times pi is 90 pi radians over 180. Again, what happened to the degrees? They canceled, and all we're left with is radians. Cool. Now there are a couple of things to note. When we work with radians, almost all the time it will involve pi in its value. So it's kind of a given that we're working in radians since our fraction has pi in it. So we can sort of erase this label just to make our work a little bit neater. All right, now it's time for us to simplify. When we simplify 90 pi over 180, we're essentially just trying to simplify 90 over 180. Okay, the reason being is because pi is just going to stay in place. It's just going to be multiplying whatever 90 over 180 simplifies to. So, thinking of the GCF between 90 and 180, we can divide top and bottom by 90. So we end up with 90 divided by 90 gives us 1 times pi in our numerator, and 180 divided by 90 gives us 2 in our denominator. Now, having 1 times anything is quite redundant, so this is the same thing as pi over 2 radians. So how does this look on our coordinate plane? There's a couple of ways to show this. First, we remember that 90 degrees goes all the way up here. So that angle measure is also called pi over 2 radians. And that is how that angle measure looks on our coordinate plane. All right. Now let's look at number 2. So again, number 2, we're going to start off with our conversion factor. We know it's 180 degrees is equal to pi radians. So let's set it up. We've got 30 degrees here, and we have to multiply it by pi radian over 180 degrees. Why is that so? Because our goal is to cancel our degrees, so we are left with our radians in our final answer. So our degrees cancel, and now we just multiply across. So if this is 30 degrees over 1, multiply our numerators across, we end up with 30 pi radian over 180. We can ignore this label, and now we want to simplify. Looking at 30 and 180, the greatest common factor is 30. So if we divide top and bottom by 30, we end up getting pi over 6. So this means that 30 degrees is equal to pi over 6 radian. So when we draw that on our coordinate plane, 30 degrees is approximately this length right here. So we could say it is equal to pi over 6 radian.